Hi, good day. So for today, we are going to talk about the charge of an element in redox reaction. Now, there are 5 primary rules that we should consider in order for us to know the charge of an element in redox reaction. The first rule is that the sole elements, diatomic elements like chlorine gas, bromine gas, iodine gas, hydrogen gas, nitrogen gas, and oxygen gas, and compounds with no indicated charge has a charge of 0. The second rule is that ions comprising a compound have charges indicated in periodic table. The third rule is that the sum of all the charges of elements in compounds or ions is always equal to the charge of compound or ion. For the fourth rule, we have here, unless it's peroxide, the charge of ionic oxygen is always -2. And unless it's hydride, the charge of ionic hydrogen is always +1. And for the fifth rule, we have here, as cations, elements from groups 1, 2, and 3 have charges of +1, +2, and +3 respectively. And as anions, elements from groups 5, 6, and 7 have charges of -3, -2, and -1 respectively. Now, let's give here an example on how we can use these rules in determining the charge of an element in redox reaction. Now, in this example, we are required to find the charge of all the elements in our redox reaction below. We have here the elements copper, chromium, oxygen, chlorine, another copper, chlorine, another chromium, and oxygen. Now, for the first one, let's have here the copper dichromate or CuCr2O7. We are going to find the charge of copper, chromium, and oxygen in copper dichromate. Now, the first rules that we are going to use here are the rule numbers 3 and 1. So again, according to rule number 1, sole elements, diatomic elements, and compounds with no indicated charge has a charge of 0. So obviously, this compound has no indicated charge, and therefore we can assume that the whole charge of copper dichromate is 0. And using the rule number 3, the rule number 3 says that the sum of all the charges of elements in compounds or ions is always equal to the charge of compound or ion. In this case, the charge of our compound is 0, of the whole compound is 0, and therefore our formula here is cation. Our cation is copper plus anion. Our anion here is the dichromate anion is equal to 0. That is according to rule number 3. Now, using the rule number 2 and rule number 3, our rule number 2 here is ions comprising a compound have charges indicated in periodic table. So, we can actually use our periodic table here to know the charge of copper and dichromate. Now, according to our periodic table, using the rule number 2, according to our periodic table, copper as cation has actually 2 charges, and those are +1 or +2. On the other hand, dichromate anion has actually a charge of -2 only. Now, the next question here is, how will we know which charge of copper did we use here? Is it +1 or +2? And so to know that, we are going to apply again our rule number 3, and that is the sum of all the charges of elements in compounds or ions is always equal to the charge of the compound or ion. In this case, the charge of the whole compound is 0. And again, our formula is cation plus anion is equal to 0. Our cation here is copper. Our anion here is the dichromate. So that's cation plus anion is equal to 0. 0 is actually the charge of the whole copper dichromate compound. Now, since our cation here, or the copper, the charge of copper here is unknown, then we can actually represent it with X. Now, how many copper do we have here? Obviously, we only have here 1 copper, CuCr2O7. But if, for example, we have here 2 copper, Cu2Cr2O7, then this is not just X, but we are going to write here 2X. If this is 3, then that's 3X. If that is 4, then that's 4X. Same with the dichromate. For the dichromate, the charge of our dichromate ion here is -2. That's why we actually wrote here -2. Okay, negative 2 is equal to 0. Now, how many dichromate do we have here? We only have here one dichromate ion. Now, if we have here two dichromate ion, that's actually 2 times negative 2. If we have here 3 dichromate ion, let's say Cr2O7, then we have here parenthesis, then 3. That's actually 3 times negative 2, and so on and so forth. But because we only have here one Cr2O7 or one dichromate ion, then that's just 1 times negative 2, and that's negative 2. Okay, now by rearranging this equation or by transposition, then we will have here x is equal to positive 2. Therefore, the charge of our copper here is positive 2. Okay. Now, however, we have here a problem in Cr2O7 because even if we know the charge of Cr2O7, of the whole Cr2O7, and that is negative 2, still we don't know the charge of Cr here and O here. Okay, how are we going to know the charges of Cr or chromium and oxygen here? To know that, okay, we are going to use the rule numbers 3 and 4. Okay, again, the rule number 3 is, okay, the sum of all the charges of elements in compounds or ions is always equal to the charge of compound or ion. In this case, we want to know the charge of Cr and O. Okay? And the charge of the whole Cr and O again is negative 2. Therefore, the charge of chromium plus the charge of oxygen according to rule number 3 is always equal to negative 2. Now, how many Cr do we have here? Okay, how many Cr can we see in our Cr2O7? Obviously, that's 2. That's why we have here 2x. Okay. Now, for the oxygen, what is the charge of the oxygen? We can actually use here the rule number 4. Okay, and according to rule number 4, unless it's peroxide, the charge of ionic oxygen is always negative 2. So, we can assume that the charge of O in Cr2O7 is negative 2. However, how many O do we have in Cr2O7? Okay, we have here 7O. That's why we multiplied it to 7. Okay, so by simplifying this equation, then we will have here 2x plus negative 14. That's actually 7 times negative 2 is equal to negative 2. Again, negative 2 is the whole charge of Cr2O7 ion. Okay, and by simplifying further this equation, then we will have here 2x is equal to 12. We actually transposed this 14 here. And by simplifying this equation, then we will have here x is equal to positive 6. This is now the charge of chromium. Okay, and therefore, the charge of copper, again, the charge of copper here is positive 2. We already determined that earlier. The charge of chromium is positive 6 according to our equation. And the charge of oxygen according to rule number 4 is negative 2. Okay. Now, for chlorine gas, this one is very easy. We can actually use here the rule number 1. Rule number 1 states that sole elements, the atomic elements like chlorine gas, bromine gas, iodine gas, hydrogen gas, and nitrogen gas, and oxygen gas have charges equal to 0. So in this case, chlorine gas is actually a diatomic element, one of the diatomic elements that we have, and therefore its charge is 0. Okay. Now, how about the copper chloride here? The copper and chlorine in copper chloride. What is the charge of copper and chlorine? Now, for us to be able to know the charges of copper and chlorine here, we can actually use the rule numbers 1, 3, and 5. Okay, what is the rule number 1 again? Sole elements, the atomic elements and compounds with no indicated charge has a charge of 0. In this case, copper chloride, CuCl2, has no indicated charge, and therefore we can assume that the charge of the whole CuCl2 is 0. Okay, it's actually 0. And so by using rule number 3 states that the sum of all the charges of elements in compounds or ions is always equal to the charge of compound or ion. In this case, the charge again of the whole compound according to rule number 1 is 0, and therefore charge of copper plus charge of chlorine should be equal to 0. Okay, 0 is actually the charge of the whole CuCl2 compound. Okay, now by using the rule number 5 states that as cation ions, elements from groups 1, 2, and 3 have charges of positive 1, positive 2, and positive 3 respectively. As anions, elements from groups 5, 6, and 7 have charges of negative 3, negative 2, and negative 1 respectively. In this case, chloride is actually an anion. Okay, and this chloride anion here, or the chlorine, is actually on group number 7. Okay, and as an ion on group number 7, it has actually a charge of -1, and therefore the charge of chlorine here or chloride ion is -1. Now, how many copper do we see here? That's just 1. That's why we have here X. Okay, our copper here is unknown, so that's why it's X. Okay, and we only have here one copper, that's just 1X. If we have here 2 copper, that's 2X. If we have here 3 copper, that's 3X. Okay, but we only have here 1 copper, so that's just X. Plus, okay, we have here the charge of chlorine according to rule number 5 is -1 because it is on the group 7. Okay, and we have here, how many chlorine do we see here? We have here 2 chlorine, so that's 2 times -1 is equal to 0. By simplifying this equation, then we will have here X is equal to +2. Therefore, the charge of our copper here is +2, and according to rule number 5, the charge of chlorine here is -1. And for the last one, we have here the CrO4. Okay, what is the charge of CrO4? For us to be able to know the charge of CrO4, we are going to use here the rule numbers 1, 3, and 4. Again, for the rule number 1, sol elements, diatomic elements, and compounds with no indicated charge has a charge of 0. So we can assume that the charge of the whole CrO4 compound is 0. Okay, and according to rule number 3, the sum of all the charges of elements in compounds or ions is always equal to the charge of compound or ion. In this case, again, the charge of the whole CrO4 compound is 0, and that's why Cr, according to rule number 3, the charge of Cr, by the way, this Q here is actually charge. Okay, charge of Cr or chromium plus charge of oxygen in CrO4 is equal to 0. Okay, 0 because that is the charge of the whole CrO4 compound. Now, how many Cr do we see here? We have here 1 Cr. That's why we have here just X. Okay, X. Plus, okay, what is the charge of oxygen? For the charge of oxygen, we can actually use the rule number 4. Okay, so according to rule number 4, unless it's peroxide, the charge of ionic oxygen is always -2. So therefore, we can assume that the charge of oxygen here is -2. And so we have here -2. Now, how many oxygen do we see here? Obviously, we have here 4 oxygen. That's why we have here 4 times -2 is equal to 0. Now, by simplifying this equation, then we will have here X plus -8. 4 times -2 is -8 is equal to 0. And by transposition, then we will have here X is equal to +8. Now, this X here is the chromium, and therefore the charge of chromium here is +8. Okay, so just a summary, the charge of our compound of our elements here are these. For copper, we have here +2. For chromium, we have here +6. For oxygen here, we have here -2. For chlorine gas, we have here 0. For copper, we have here +2. For chlorine here, we have here, or chloride ion, we have here -1. For chromium, we have here +8. And for oxygen, we have here -2. Now, obviously, there are ions or elements in this equation that did not change their charges after this redox reaction. Like, for example, the copper in the reactant side has a charge of +2, while on the product side, it still has a charge of +2. Same with oxygen, we have here -2 on the reactant side, and on the product side, we still have here -2. Now, those ions or elements that did not change their charges after a redox reaction is what we know as spectator ions or spectator elements. Now, determining the spectator ions or elements and the charge of the elements are very important skills in balancing complex redox reactions. So those are the things that you need to know about the charge of an element in redox reaction. Thank you for listening and good day.